Hi, my name is Xander. This is my Nueva MyPage. This MyPage will be about Science Olympiad. Science Olympiad is a event-based competition which you have to try out for, and there are two big groups of people. Each of them has 15 people in it. Each person has 3 or 4 events. So my 3 events are Road Scholar, Density Lab, and Elastic Launch Gliders. Road Scholar is an event where you take a map and you answer a bunch of questions about it. Density Lab is it's an event where you take a test and there's a lab, and you use the test lab to try to answer the questions about density of materials. The event we'll be talking about the most is Elastic Launch Gliders. Elastic Launch Gliders or gliders is an event where you take a glider and you build a glider out of balsa wood, carbon fiber, and optionally paper. You also will use glue and clay and trims to make it more balanced. The goal of Elastic Launch Gliders is to launch the glider into the air and have the longest air time possible. Distance doesn't matter, so when you launch the glider in the air, the most effective strategy is to lose all momentum and have it slowly spiral down. Me and my partner won a medal at the Churchill Invitational in December. Now I'm going to describe my glider. This is the nose. I added clay to it to make it a little bit heavier, and as you see, the clay on each side is different, because if there's more clay on this side, it will turn easier, which I'm going to show you in the launching stage. This is the fuselage. It's made of carbon fiber, because carbon fiber isn't very flexible and very strong and very light, to create a hard, stiff structure for the plane. These are the wings. They're half made of wood and half made of paper, because the wood provides structure for the wings and the paper is lighter than the wood. So adding paper makes it lighter and fly better. And this is the tail. It's same as the wings, made of wood and paper. The 2 parts are the horizontal stabilizer and the vertical stabilizer. Yeah, that's my glider. So we get these gliders out of a kit. The build is very careful. It's very complicated, and you have to be very careful while building them. But the big difference between our gliders and everyone else's gliders and our gliders is how much you tune them. You add clay when you tune them. When you tune them, you fly them. You tell it's doing something you don't want, whether it's nosediving because there's too much weight here, stalling because there's too little weight here, and you go up because this part's heavier, and then you lose all momentum and you fall straight down. If there's nosediving, you have to take weight away from the nose. If it's stalling, you have to add weight to the nose. Whether it's turning well or not, how tight it's turning. There's a bunch of factors that you have to tune. And you have to tune your glider to make it do the right performances. The big problem with making gliders is that they're made of wood and paper, and they're really easily breakable. Like here, it broke. Now we're gonna have to fix it later. I've had many gliders throughout. I've broken gliders. I've flown them into the wall at the wrong angle. If the brake isn't clean and the jagged shards fall off and you don't get the whole piece in, you can't fix it properly. So you have to take apart the glider and rebuild it. Now let me show you some examples of my flights. This is how it's supposed to properly look. It goes straight up into the air and slowly circles down. In this clip, the vertical stabilizer is not turned enough, so the glider goes straight into the wall. In this clip, the bank angle is too high, so the glider goes up, starts turning early, and then goes straight down. And finally, This is a clip where the glider does what it's supposed to do. It flies upward, levels out, goes in circles, and stays up in the air for long enough. So, our last competition in December, the Churchill Invitational, I did well in gliders. So, the days before the competition, we didn't know how high the roof would be. And since you're trying to fly it really high up and it slowly circle down, if you think the roof is higher than you think it is, you're not going to get as much lift as you can, and it's less time. If you think it's lower than you think it is, you're going to run the glider into the roof, and it will fly straight down after that. So we created a bunch of things. Like if it's 20 feet, this is probably the right angles. If it's 22 feet, this is probably the right angles. And so we came to the and we did lots of work and got all the right angles. So when we came to the competition, I was a little nervous because it was right between two of our heights. So we got it ready, and we flew the glider, and we just put it right between the angles right between, and it flew beautifully. And we got a 4th place medal on 33 teams, which I'm really proud of. And we're building more gliders. Our gliders are flying better, longer, and and I'm ready for the future competitions. The biggest reason I like Science Olympiad is that you're allowed to go in depth in a series of topics, whether it's aeronautics and elastic launch gliders, density and gas laws in Density Lab, or cartography and Road Scholar. We're going in depth in subjects that we never study actually in school. Thank you for watching my video.